Okay, so lesson 9, basic properties of similarity. We're going to work through these exploratory challenges together. So here we go. The goal is to show that if triangle ABC is similar to triangle A prime, B prime, C prime, then ABC is similar, or A prime, B prime, C prime is similar to ABC. Symbolically, if triangle ABC is similar to triangle A prime, B prime, C prime, then triangle A prime, B prime, C prime is similar to triangle ABC. So we're just proving it kind of backwards. So we're going to look at this diagram, and it says, first determine whether or not triangle ABC is in fact similar to triangle A prime, B prime, C prime. If it isn't, then no further work is needed to be done. So we need to see that they're similar first. Use a protractor to verify that corresponding angles are congruent and that the ratios of the corresponding sides are equal to some scale factor. Okay, so pull out your protractor. Okay, we're going to do some measuring. And then we're going to look at the sides. So I'm going to start with angle A, okay, in both triangles, A and A prime. Okay, so we have A here, and we have A prime here. So obviously, definitely not extended out enough to measure. So I'm going to use the straight edge to extend out all of the sides so I can measure accurately. Okay, so I'm going to line up my center, move this back over here, line up my center with A, and line up the edge over here at 0, right here, with the line. Okay, and then I'm going to measure. So 10, 20, 30, 40, looks to be about 49 degrees. Angle A equals 49 degrees. And then I'm just going to list them all out. So angle B, angle C. I didn't extend the right one. Angle B. Okay, and I'm measuring on the inside of the triangle, so that's why I'm going to start here, because I want to know this amount, not this amount. I want to know the amount where it's gray. So 10, 20, 30, 40, 90, 5, 6, 7, 8. So down here, 98 degrees. That's a band. Probably too young to know who that is, but it's a band. And then I'm going to do the same thing over here. I want to know the angle right here, so I'm going to start over here, 10, 20, 30, 1, 2, 3 degrees. Okay, and then I'm going to measure the same thing, same angles over here. Angle A prime, angle B prime, angle C prime. So I'm going to extend out my lines. Alright, so angle A, barely long enough to reach over here. I'm going to extend them further because I want to make sure that I have the correct measurements. So line up A, with the lines on each end. I want to know here, so I'm going to start here. 50, 49, 50. So that's 49 degrees as well. You can't see that. 49 degrees there. Angle B. Oh, got it extended this way. Angle B. We're going this direction. And you line this up. If your lines aren't long enough, you might have it off just a little bit. See, like I can line this up, but it's not correct. So if I adjust it, the bottoms here, then I can measure. And again, I come up with 98 degrees. I wrote that down here. Then we got to measure C. I'm going to turn my paper and measure C. So here, we're going this way again. Measure correctly a while ago. Let's see. I did not. It was 33 degrees. Oh, I did write 33. So 33 degrees. This one was 33. I was double checking. Whew. Okay, so then we're going to look at our sides. Okay. So I'm going to look at corresponding sides. So side AB equals 4. Side A prime, B prime is 2. Side BC is 6. B prime, C prime is 3. Side CA is 8. Side C prime, A prime is 4. So they have the same angle measurements, and if I take each of these and divide them by, or multiply them by a scale factor of 1/2, we get 2, 3, and 4. So they are similar. B says, describe a dilation of followed by a congruence that proves triangle ABC is similar to triangle A prime, B prime, C prime. Okay, so I'm going to change colors. Okay, so we're going to have a dilation first. And we somewhat already talked about that. I already described that. Dilate triangle ABC from center O. You got to include your center. And if we look at our measurements here, okay, to go from AB to A prime, B prime, it was a scale factor of 1/2. So a scale factor of, with a scale factor R equals 1/2. That's our dilation. So now I'm going to go over here and actually dilate it. Okay. So A is at -4, 6. So half of that would be negative 2, 3. B is at negative 8, 4. So negative 4, 2. And C is at negative 6, negative 2. So half of that would be negative 3, negative 1. So we would dilate it and we would get this shape. Okay? Then we want to show that this new one, the green one here, will overlap with this one. So I would then do my congruence. Okay? And to me,